And a stack is called as ordered list of stack is a dynamic linear data structure, and stack is also list of same element which are ordered and and all the operations like insertion and deletions, all the operations like insertion and deletions are permitted only at the end of the list, only at the one end of the list. The meaning is Stack follows a principle called as LIFO. Sense last in, first out. Last in, first out. Dynamic linear data structure. Elements, same type of elements, and which are ordered elements, so stack follows LIFO order. That means the last inserted element will be first out. Inserted element will be first out, and all the operations like insertion and deletions will possible. Okay, all the insertion and deletion possible at one end only, the meaning is that one end is nothing but top of the stack. The meaning is, from the top of the stack we will insert the element. Okay, to the top of the stack we will insert the element. From the top of the stack we will delete the element. So at the place of top, so now you can observe stack is a collection of similar data items. So stack is a collection of similar data items in which both insertion and deletion operations are performed based on the LIPO principle, and all the operation is possible only on top of the stack. So this is the definition of the stack. Linear data structure. Stack is a dynamic linear data structure. So stack can be called as collection of similar data elements, which are ordered, which are order. All the insertion and deletions must follows the LIFO principle, that is nothing but last in, first out. Last in, first out. Okay, simple. Simple. Where we use this stack, so we can use the stack in balancing the symbols. We can use the stack data structures. We can use the stack data to postfix and infix to prefix. We will discuss what is infix and what is postfix and what is prefix. Okay, so we can use this stack in infix to postfix or infix to prefix conversion. Okay, we can use and we can use in redo and undo features, and forward and backward features, Okay, so those are available in the browsers. And do undo like in a Photoshop, and used in many algorithms like Tower of Hanoi and tree data structures, as well as night tour. There are some advanced algorithm. To those advanced algorithm, so basics like N Queen's algorithm, so Tower of Hanoi algorithm, so tree traversal. So there are so many algorithms are implemented based on this. So stack can be used in many application. Like redo, undo, and backward and forward, as well as forward and backward, infix to postfix or infix to prefix conversion. So like that applications uses stack internally. So very important. So stack follows only one principle called as last in, first out. Okay, so the insertion, what are the operations we can perform? So we can operations majorly two operation. So one is push and another one is pop operation. The push operation is nothing but insertion, and pop operation is nothing but deletion. So these operations will possible only top of the stack. Only top of the stack. That is the meaning of we will insert the element into the stack using the top element at the place of top, and we will delete the element, at the place of top only, So like assume these are the main operation, so let us assume this is the stock, this is the stock. Generally, we'll create the stock by using the arrays. Generally, we'll create the stock by using the arrays concept. You can observe these are the indexes 0, 1, 2, 3, 4. So totally the size of the stack is 5. The size of the stack is 5. And we will insert the element. From the from the top of the stack. From the top of the stack. So meaning is, so first we will insert 10, 20, 30. So 30 will become the top. So we will insert here, we will insert and we will insert like this. So okay. So just don't be confused. Don't be confused. So what is a stack? Stack is a dynamic linear data structure. Dynamic linear data structure, and stack can be called as ordered similar data element. So ordered similar data element. Stack can be used in many application. Stack can be used in many application like infix to prefix or infix to postfix conversion, or redo or undo operations, and forward and backward operation. And so generally we can perform two majorly operation, that is push operation, nothing but insertion. The second one is pop operation, that is nothing but deletion. Okay, the insertion and deletion we will perform only one end, with only one end of the list, that is nothing but top of the stack. That is nothing but top of the stack. So from the top only, we will insert the element. From the top only, we will delete the element. So you can see here, so empty stock, if it is top equals to -1. For full stack, top equals to max size -1. The meaning is, let us assume, I am creating one stack here. So with the size called as 5. Totally, how many elements I can store? 5 elements. So index start from 0. So 0 to 4. 0 to 4. So when I say max size is 5, the top will become the 5 minus 1. The top will become the 5 minus 1. The fourth index will become the top of the stack. The fourth index will become the top of the stack. And 4, 3, 2, 1, 0. Up to 0 we can insert the element. So first we will insert in the fourth location, and we will insert the element into the third location, and we will insert the element into the second location, and we will insert the element in the first location. As you can see here, so while you performing the insertion, మీరు ఎప్పుడైతే ఇన్సర్షన్ చేస్తున్నారో, సో టాప్ అనేది ఏమైపోతుంది, తగ్గుతుందా పెరుగుతుందా? సో టాప్ ఇండెక్సెస్ అన్ని ఏమవుతున్నాయి, తగ్గుతుంది. ఎస్ ఆర్ నో? సో ఫస్ట్ టాప్ సైజ్ ఎంత? 5 minus 1. సో ఫస్ట్ ఏంటి, టాప్ ఈక్వల్స్ టు 4. సో 4 minus 1 3, 3 minus 1 2, 2 minus 1 1, 1 minus 1 0. That stock is empty. That stack is empty. So the top equals to size -1. The top equals to size -1. So when it reaches, so 4 minus 1, sorry, 5 minus 1, the stack is full. Okay, right, right. There are two concepts.
stack overflow and stack underflow. Stack overflow and stack underflow. So what is overflow? When the stack is full and user still try to push an element. When the stack is full, when the stack is full, still user want to insert an element. Insert an element. So that is nothing but overflow. So why? Because overflow. So top equals to max size minus 1. If any elements are available at this position, okay, up to fourth position, we should enter the element, right? Up to fourth elements we can insert. If I try to insert the fifth element, if I try to insert the fifth index element, so it will become stack overflow and stack underflow. There is nothing, but still you want to retrieve or you want to delete something from the stack, then it will become the underflow. Then will become it as the underflow. So just a minute. Let us assume. So let us assume this is the stack. This is the stack. I have a stack with 5 sizes. Okay, right? So this is a stack. This is stack with 5 elements. With 5 elements. So top will become 5 minus 1. 5 minus 1 equals to 4. Okay, the indexes always start from 0. The indexes start from 0. This is 0 index. This is 1 index. This is 2 index. This is 3 index. And this is finally 4th index. So what is the top of the stack? The 4th index is the top of the stack. From this top, we can insert the element and we can delete the element. We can insert the element or we can delete the element. So there are only two operations as well as pop operation. Push operation as well as pop operation. That there is peak or top. Will return the top of the stack. Will return the top of the stack. Will return the top of the stack. Simple. And you can use a display function. We can use a display function to display all the elements from the stack. Okay, so majorly these are the operations we can perform using the stack. The first one is push operation, nothing but insertion. Pop operation, nothing but deletion. And peek operation, nothing but retrieve the top of the stack. And display method, so which is used to retrieve all the elements from the stack. All the elements from the stack. Suppose let us assume the stack is created. The stack is created. There are no elements. Only stack is created. Empty stack is available. Empty stack is available. I'll try to delete. I'll try to call a method called as delete. Actually, we should enter the element and then you can delete the element, right? So before entering the elements, directly I try to call which method here? Pop method. Pop method used to delete the element from the top of the stack. Is there any element? There is no element in the stack, but still able to I can try to delete the element. So
from this stack without any elements. Without any elements. So that will is nothing but a stack is empty. Stack is empty, or stack is nothing but underflow. The stack is nothing but underflow.
Why? So underflow. When the underflow, when the stack is empty, and user try to pop.
The condition is called as stack underflow or stack empty. When you when you say when the stack
The stack, still user want to pop element of the stack. That condition is called as stack underflow. Stack underflow. How many elements you can store here? How many elements you can store here? We can store 4 elements or 5 elements. Let us assume 10, 20, 30, 40, and 50. Let us assume there are 5 elements we can store. So there are elements are called as 10, 20, 30, 40, and 50. So if I try to insert one more, if I insert one using the push operation, I try to enter 60. I try to enter 60. So stack is full. Stack is full. All the elements are placed in the size of the stack. There is no place to insert the new element. There is no space to
overflow. Stack is full or stack is overflow. So this is the condition. This is the condition. When the stack, the condition is called as stack overflow. So take the notes. Take the notes. Stack. What is the definition? So write down the definition. Stack is a collection of similar data elements. Stack is a collection of similar data elements or items in which both insertion and deletion operations in which both insertion and deletion operations performed under LIPO principle. Both insertion and deletion operations performed under LIPO principle. LIPO principle. Next slide. LIPO lost in first out. LIFO lost in first out. Structure of a stack. Structure of a stack. Structure of a stack. Next slide. Stack is also called as stack is also called as next slide. Stack is also called as dynamic linear data structure. Stack is also called as dynamic linear data structures. Dynamic linear data structures. Next slide. we can perform we can perform following operations using stack. We can perform following operations using stack. First one, push. First one is push inside the bracket insertion. First one is push inside the bracket insertion. The second one is pop. The second one is pop. The second one is pop inside the bracket deletion. And third one is peak. Third one is peak. Retrieve the retrieves the top of the stack. Retrieves the top of the stack. Retrieves the top of the stack. And fourth one, display. Fourth one is display. Traverser of a stack. Traverser of a stack. Fourth one is display. Fourth one is display. Fourth one is display. Traverser of the stack. Take this diagram. So, right, right. So next, stack overflow and underflow. Stack overflow and underflow. Stack overflow and underflow. Next heading, stack overflow. Stack overflow. Stack overflow. This occurs. This occurs. This occurs when user try to push. This occurs when the user try to push a new element. New element. This occurs when the user try to push a new element to the to the full stack, to the full stack underflow. When user try to delete when user try to delete or display when user try to delete or display operations when user try to delete or display operations performed on empty stock performed on empty stock performed on empty stock is called underflow is called underflow when it is called, so it is called underflow. So take this one, it reaches top equals to -1, it reaches top equals to -1, it reaches top is equal to -1. Okay, so simply, so listen, when the top equals to max size -1, that will is nothing but overflow. When the top returns -1, that is nothing but stack is empty. If the top returns -1, stock is empty. If the top returns max size -1, that is nothing but stack is full or stack is overflow. Okay, so blindly you need to remember this. So next heading, applications of stack. Applications of stack. Next heading, applications of stack. Next heading, applications of stack. Applications of stack. Stack can be used in stack can be used in stack can be used in following applications. Following applications. First one, balancing the symbols. Balancing the symbols. Second one, infix to prefix or infix to postfix conversations. Infix to prefix, infix to prefix or infix to postfix conversations. Third one, first one is balancing the symbols. Second one is infix to postfix or infix to prefix conversation. The third one, undo and redo features. Undo and redo features. Undo and redo features. Undo and redo features. Fourth one. Fourth one. Forward and backward. Forward and backward features. Forward and backward features. Next one. Used in many advanced algorithms. Used in many advanced algorithms like Tower of Hanoi, n Queen's problems. Used in many advanced algorithms like Tower of Hanoi and n Queen's problems. Tower of Hanoi and n Queen's problems. N Queen's problem. Okay. So majorly we can perform push operation and listen here. Majorly we can perform push operation and pop operation. The push operation is nothing but storing or inserting the element into the stack, and pop operation is nothing but removing the element from the stack. The insertion and deletion will be happen from the top of the stack. Insertion and deletion will be happened at the top of the stack. So meaning is మీరు ఇన్సర్షన్ చేయాలన్నా డిలీషన్ చేయాలన్నా మీరు ఫస్ట్ ఫైండ్ అవుట్ చేయాల్సింది ఏంటి? టాప్ని ఫైండ్ అవుట్ చేయాలి. ఏం ఫైండ్ అవుట్ చేయాలి మనము? టాప్ని ఫైండ్ అవుట్ చేయాలి. దెర్ ఆర్ టూ కండిషన్స్. టాప్ ఈక్వల్స్ టు మ్యాక్స్ సైజ్ -1. మీనింగ్ ఈస్ overflow. Top equals to -1 is equals to underflow or stack is empty. ఎప్పుడు ఇన్సర్ట్ చేస్తాము? When the stack is empty, we will go for the insert. When the stack is full, we will go for the delete the elements, right? But stack follows what? Last in, first out. Stack follows what? Last in, first out. So the procedure to perform the push operation, we will check whether stock is full or not. First step, we will check the stock is full or not. If the stack is full, we will not perform any new operation. Directly will display stack is full. If the stack is not full, if the stack is not full, we will increment, we will increment top to point, top to point next empty space, next empty space, and add the element to the stock location where the top is pointing, and return the success, and return the success. The meaning is, the meaning is simple here. We will create one stock with the fixed size. Let us assume my size, max size. So max size equals to 3. How many elements we can store? 3 elements. 1, 2, and 3. Stack is created. The stack is created. The top will become, the top will become -1 initially. The top will become -1 initially. The top will become -1 initially. Okay. I will declare the top will become the -1, so that the indexes start from 0. The indexes start from 0, 1 and 2. 1 and 2. The top is not pointing to the any location. The top is not pointing to the any location. In order to perform the push operation, in order to perform the push operation, first we will check whether stack is full or not. How to check whether stack is full or not? Simple. We will write the condition top, if top equals to max size -1. What is the top? The top is nothing but -1. I'll try to check. The top equals to max size -1. So -1 equals to, what is the max size? Max size is 3. 3 minus 1, 2. So -1 equals to 2. The condition is false. The condition is false. The meaning is stock is not full. The stock is not full. Okay. Then what we need to do? If the stack is not full, if the stack is not full, we will increment the top. We will increment the top to find the next empty space. To find the next empty space. What is the top? What is the top now? The top is minus 1. We will increment it by 1. So increment. So minus 1 to 0. Minus 1 to 0. Minus 1 plus 1 is nothing but 0, right? So we will increment the condition. We will increment the top position so that top will point top will point to the 0 position. Top will point the 0 position. Within this 0 position, we will insert the element. We will insert the element. We will insert the element. Next, same condition. Now top will become 0. Top will become 0. Again, we'll check the condition. Top 0 equals to 2. So stack is not full. Stack is not full. So we will increment 0 to 1. We will increment 0 to 1. So now top will point to the 1. Top will point to the 1. And we can implement and we can perform a new operation, a new element 20 to the 1. And again we will check the condition. Now top will become 1. So 1 equals to 2. Again stock is not full. Again we will increment the top. Again we will increment the top. So now top will become 2. Now top will become 2 and the pointing to the second location and we will insert the element. We will insert the element. Again we will check the condition. Top will become 2. The 2 equals to 2. So that condition is true, that the case stack is full, or we can say stack overflow. Stack is full or stack is overflow. So what is the procedure? So to insert element into the stack, to insert elements into the stack, every time you need to check whether stack is empty or not. If the stack is empty, space available or not. If the space is available, we will increment the top so that top will point to the particular location. Within that location, we will place the element. We will place the element. So otherwise, we will display the stack is full or stack is overflow. So this is the procedure. This is the procedure. So write on the position, write on the procedure, push operation. Push operation. So take only the steps. Take only the steps. Step 1, step 2, step 3, step 4 and step 5. So complete this step. Complete the steps. Take this diagram.
Hello everyone. Good morning. Good morning. Good morning. So let me introduce myself to you. This is Govin Kornu, and I am passed out of 2025 batch, who is recently placed in Microsoft as a TSE. So thank you. So Kite invited me as a guest today to participate in an event. I just want to have a word with you. Just want to share my experience in my college. I hope it might be useful for one person. So he can be rolled back to the college after his fourth year. I hope it's not one person, entire class. So the thing is, I started my career as uh, I started my career in CEO company and then Sutherland for 4 months, and then Genpact, and then rolled back to Microsoft. I got a college placement of CEO and Sutherland in our college in Sutherland, and then I rolled back to Microsoft while I'm doing Sutherland job. So the thing is, when I was sitting in your foot, what are the activities that help me a lot means the first thing is tech to learn. To learn. Everyone will say, no, tech to learn really helped me a lot. Because you are all first years, right? Everyone is first years. Everyone are hostlers and day scholars, right? So the thing is, when I'm in my first year, in our class we'll have leads, CMs. So if the class is 50 minutes, lecturer used to teach for 30 minutes or 40, 35 minutes. The last 10 to 15 minutes were for students. They need to explain here what they understand. I think that is continuing from them, I think so. It might be in some of the classes. So the thing is, it helped me a lot. With that experience, one day Dean sir saw me while I'm giving some lecture in the board after completion of the class. And in the second year, first day itself, just after 8 months of my college joining, I joined in 2021 December. In August 2022, that is just 8 or 9 months, I was a faculty in the college who is teaching mathematics for my juniors. I used to deal 4 sections, that to M1 subject. I know you're having R22 paper, right? R23. R23. So R20 M1 is somewhat different. You might ask your seniors who is having fourth year now. That is somewhat difficult. I saw them R23. For you, I think M2 is difficult, right? Or M1 also difficult. M1 also difficult. Let it be. So I, I was a faculty for 2 years in the college. I was a maths faculty when I'm pursuing my degree. When I'm in a second year, I used to teach first year students 4
and we can add the element to this stack location, and we will return the success. Okay. Right. So we will declare, initially we will declare the top with -1, the top with -1. We will increment every time. The top will become 0. We will insert the element 10. And we will increment the top again. The top will become 1. We will insert the element. Again we will increment the top. Again we will insert the new element, so that the stack is full. We'll try to again increment the top position, and we will try to insert new element, so that the case the stack is overflow or the stack is full. Okay. Next, the pop operation, we will check if the stack is empty or not. If the stack is empty, we will display whether stack is empty or whether stack is no elements. If the stack is not empty, we can access the data element which top is pointing, and decrease the value of top by 1. So in the case of insertion, in the case of insertion, we will increment the top. In the case of insertion, we will increment the top. In the case of deletion or pop operation, we will decrease the top. We will decrease the top. So there we will check, there we will check whether stack is full or not. So here we check the stack is empty or not. So there will increment by 1. So here will decrement by 1. So in increment, we will do the operation. Okay. In in push operation, we will increment and we will perform the push operation. In pop, we will decrement and we will perform the pop operation. So take the steps. Pop operation using stack. Pop operation using stack. Pop operation using stack. Right. Do not talk. As your senior said, I'll give the class session to some random people. At the end of the session, they'll come here and they'll explain. I will select the people. Got it? I'll select based on your activities. If you listen the class, I'll leave. If you not listen the class, definitely I'll hire you to discuss here. You wanna test? I can easily recognize who is listening and who is not listening. So concentrate. So majorly push operation and pop operation. So in the last example, so let us assume same scenario. Let's assume scenario. Stack is available. Stack is available with three elements. Stack is available with three elements. Let us assume like 30, 20, and 20 and so max size is 3. Max size is 3. And initially I'll declare a top with max my max size minus 1. Initially I'll declare the top with max size minus 1. So this will become 2. This will become 2. So this is what initial stage. This is what initial stage. This is what initial stage. Let us assume the starting stage. In the push operation, the initial stage top will become minus 1. In the pop operation, the top will become max size minus 1. And, and we will check the condition whether stack is full or empty. If it is a pop operation, we will check whether stock is empty or not. When it is empty, when top will becomes minus 1. When top will becomes minus 1, I'll check the condition. If top equals to minus 1, so this is the case, the stack is empty. So if the stack is not empty, we will decrease the, so what is the steps? We will, if the stack is not empty, we will access the data element at the top is available and we will decrease. Okay, so the condition is false. The condition is false, so that we'll try to retrieve the element. We will try to retrieve the element. So let us assume this is the stock. Let us assume this is the stock. So stack of top. Stack of stock. So what is the top condition? So it returns to, it returns to the stack of 2 pointing to the 30. So 30 will be deleted. 30 will be deleted. So after accessing the element, so pop operation means we are performing what? Pop operation. So we will perform the pop operation from the top of the stack. So initial stage it is 2, the 30 will be deleted. So now the top element decrease by 1, that is nothing but 1. So now top will point to second position, that is nothing but stack of top. Stack of top. So we will decrease here top minus minus. Top minus minus. So 2 will become 1. 2 will become 1. So it will point to the 20. So first position. So it will delete the element. Again, after accessing and after deleting the element, top will decrease by 1. So it will become 0. It will become 0. And stock of stock of top, that is nothing but it will point to the, so 0 position, and it will delete the first, so first index, it will delete the element from the first index. Every time we will perform the pop operation. Every time we will perform the pop operation. So next, we will decrease again the top. We will decrease again the top. So top will become, so top will become minus 1. So top will become minus 1. Top will become minus 1. When is top will become minus 1, this indicates stack is empty, stack is empty, or stack, what is the condition? Stack under flow. Stack is empty or stack is under flow. So in the push operation, we will increment the top and we will perform the push operation. In the pop operation, we will decrease the top and we will perform the pop operations. So this is the procedure you need to check. So at part of the pop, you need to mention the initial size is max size minus 1, and we will check the condition is called as top equals to minus 1. And when coming to the push operation, we will check the condition whether top equals to max minus 1 and initial stage will start with minus 1. So take this diagram. So, right. So, what is the definition of the stack? The stack is a collection of similar data elements which follows all the insertion and deletion operations performed under LIFO, last in first out, last in first out. And stack is also called as dynamic linear data structure. By using stack, we can implement so many applications like balancing the symbol, undo and redo, backward and forward, and so many advanced algorithms we can use this stack. So majorly we can perform push, pop, pick and display. So display in a sense all the elements we can display the elements from the stack, and pick element is used to retrieve the top of the stack, and push operation and pop operation will be performed at only one end, that is nothing but top of the stack, that is nothing but top of the stack. So while inserting the data, we will increase the top. We will increase the top and we will check whether top equals to max minus 1 or not. And while performing the push operation, we will decrease the top and we will check whether top equals to minus 1 or not. Okay, so these are the things you need to remember. These are the things you need to remember. Right. So we will see the program here. We will see the program. Simple. So what we need to do is we need to create a stock. We need to create a stack. Actually, we have two options. Actually, we have two options. One is stack using arrays. One is stack using arrays. Okay. So simple. As define, I am defining the size. What is the size of the stack? 5. So initially I am checking top equals to minus 1. Meaning is, hmm, so into stock of size. What is this? What is this? This is size. This is top. And this is stack. And this is, this is size. This is, this is, then this is stack size. Then what is this? Hash include std. What is this? Header. Then what is this? Header file again. Define. Include. This is called as pre-processors. Right? ఏమంటాం దీన్ని? So, okay. What is this? మళ్ళీ టాపా? It is just a variable. What type of variable? Integer variable. What is the value? Minus 1. Then what is this? Stack is a variable. Stack is a variable of type. What type of variable it is? It is array variable. We are using the dimensions, right? Yes or no? We are using what? Dimension. The dimension means array. What is the array? Integer array. Integer array with the size called as 5. With the size called as 5. So we are creating the array here. The array name is, but it is not a stack directly. Clear? Clear. We are creating what? Array or stack? Array. What is the array name? Stack. What is the size of the array? How many elements we can store? 5 or 4? 5 or 4? 5 elements. 0 to 4. 0 to 4. 5 elements we can store. 0 to 4. In order to perform push operation, we'll always check. We'll always check. The top must be less than size minus 1. Yes or no? Size minus 1. Will increment or will decrement? In the push operation will, in the pop operation will decrement. Top plus plus. Initially top with minus 1. So top will become 1 or 0. 1 or 0. So what is the initial value? Minus 12 will become 0 or 1. సో నేను ఏది చూపిస్తే అది బ్లైండ్గా నమ్మొద్దు. సో టాప్ విల్ బికమ్ 0. టాక్ అప్ టాప్. స్టాక్ అప్ టాప్. స్టాక్ అనేది ఏంటి ఇక్కడ? అరే వేరియబుల్. అరేలో ఏ ఇండెక్స్? టాప్ ఈస్ నథింగ్ బట్. సో అరేలో 0 ఇండెక్స్లో ఏం స్టోర్ చేస్తున్నాం మనము? సో వాల్యూ ఎక్కడి నుంచి వస్తుంది మనకి? వాట్ ఇస్ దిస్? What is this? What is this? Push operation. What is this? Void. What is this? It is a return type. It is a function name. So we are declaring the function. We are declaring the function. What is the function name? Function name is. And what is the input parameter? Value. That is nothing but integer we need to supply. Integer we need to supply. So this is what function declaration. This is what function declaration. If the top size minus 1, that means nothing but stock is not full. Stock is not full. We can insert the element. So we will increment the top and we will try to insert the value. And after that, we will display the statement. Element pushed successfully. If it is condition is false, that means stack is overflow. What is the meaning of overflow? Top equals to what is the size? Size is 5. When the top equals to, when the top equals to 4, the stack is got the code or not? So next, another function. What is the function name? Pop. We are checking the condition whether top greater than 0. Whether top greater than 0. So we will decrement the top. We will delete and we will decrement the top. If it is condition is fail, stack is underflow. And peak operation, the peak operation always return top of the stack. Will return top of the stack. If it is greater than 0, it will return the index top of the stack. If it is not, it will always return minus 1. Minus 1 means when it is minus 1, when it is equals to minus 1, empty or not? When the stack is empty, it always return minus 1. And what is another function? What is another function? Display start from where? Top greater than or equal to 0 minus minus. So percentile D stock of I. Stock of I. Now stack is just a array. Stack is just a array. So by using arrays, we can represent the stack here. We can represent the stack here. So how many operations? 4 operations. Push, pop, pick, and display. And coming to the last, these are all what? declaration of the methods. And finally, what is the method? Main method, choice and value. What is the first choice? What is the first choice? Push. What is the second choice? What is the third choice? What is the fourth one? What is the fifth one? So we will enter the choice. It will read directly by using the scanf, and based on the choice, it will call the method. If it is one, it will call the push method, and immediately it will call the display method. If it is option 2, it will call the pop operation and immediately call the display method. If it is value, if it is 3 option, it will call the pick and no need to call the display method. The top will be retrieved and display. And the fourth method especially for display. And the fifth method is nothing but exit the program. Exit the program. So any remaining inputs, these are invalid. Those are invalid. So simple. Why we are calling pop immediately pop to the display or immediately display to the push? Why we are calling again and again display? Why? Because we will check and we will verify whether particular element is inserted successfully or not, whether particular element is deleted or not. For demonstration, we are calling the display function here. So simply go to the terminal. So new terminal, go to the terminal and new terminal. So gcc space, what is the file name here? Stack underscore array dot c. So stack underscore array dot c. So I'll execute, I'll compile this program. Successfully compiled. A.exe. So it is asking about whether you want to push or whether you want to pop or whether you want to pick or whether you want to display. So nothing is inserted. I'll try to delete the element from the stack. So it will display stack underflow, stack is empty. So suppose I'll choose the choice called as display. Again, enter your choice is for stack is empty. So first choice, enter value to push. I'll enter 100. So stack elements are 100 is elemented. And again, first choice 200. So 200 is top and 100 is second. So meaning is insertion is happening to the top of the stack. And again one option 300, 300, 200 and 100. So last in, first out. Last in, first out. I'll enter 2 here. I'll enter 2 here. So totally how many elements are available? 300, 200 and 100. So last inserted element is 300. So when I try to push, the element 300 is popped successfully. So 300 is gone and the remaining elements are 200 and 900. So simply I would like to display, the stack elements are 200 and 100 so that I can exit the program. The simple program is simple. The program is simple. So simply we should declare one header file. We should declare one size is a predefined, okay, preprocessor or predefined. The sizes can be anything. I'll continue with 5. And after that, initial stage, top is -1. And I'll create the array with the same size. I'll create the array with the same size. I'll try to provide the push operation. I'll always check the condition. If the top equals to size -1, then I'll increment the top. I'll try to insert the value, and then if it is condition is false, I'll try to display stack overflow. If it is a pop, I'll decrement the top until unless it reaches -1. Until unless it reaches -1. So it reaches -1, we will display stack is underflow. The peak is used to retrieve the top of the stack, and display method is used to retrieve all the elements from the stack. So take this program. Very, very important. The program is very, very important. You will get a question in the examination. సో ఎన్ని ఆపరేషన్ చేస్తాం స్టాక్లో?
హలో.
వాట్ ఆర్ ది ఆపరేషన్స్ యూజింగ్ స్టాక్? ఏమేమి ఆపరేషన్ చేస్తాం చెప్పండి. వాట్ ఆర్ ది ఆపరేషన్స్ వీ కెన్ పర్ఫార్మ్? పుష్, పాప్, పిక్ అండ్ లే స్టాక్ డెఫినేషన్ చెప్పు. అదే స్టాక్ డైనమిక్. ఇంకా నోట్స్ ఇది, నోట్స్ మీదే, నీ ఫ్రెండ్ది కాదు నీది. ఏం రాసావు? కొన్ని రాసినా కదా. అండర్ ఫ్లో, ఓవర్ ఫ్లో అంటే ఏంటి రాసావు కదా, అండర్ ఫ్లో ఓవర్ ఫ్లో అని. ఫస్ట్ ఫస్ట్ పీక్ రాయలేదా? సైలెన్స్. ఎవరిని అడిగినా క్వశ్చన్స్ చెప్పరు, అటువంటి వాళ్ళని అడుగుతా. నాకు తెలుసు కదా ఎవరు వింటున్నారు ఎవరు వినట్లేదని. ఈవెన్ క్లాస్ విన్న వాళ్ళని కూడా అడగొచ్చు నేను. సరే, ఓకే. సో రైట్ ఆన్ ది ప్రోగ్రామ్ ఫస్ట్ వి విల్ ఆస్క్ ఛాలెంజ్. ఎవరు కూడా నేను అడిగే క్వశ్చన్స్ ఆన్సర్ చేయలేరు. మాట్లాడద్దు. ఇంకా రాయలేదా? అయిపోయిందా? 1:30కి వచ్చేవాళ్ళు క్వశ్చన్ ఆన్సర్ చేసి లోపల రావాలి. సరే, క్లాస్ ఎగ్గొడదామనే కదా. స్క్రోల్ చేయనా?